All right, we're going to start off with looking at the rational function in the general form. So there are two ways of writing the rational function. The first one I showed you was the standard, and the rational in the general form just looks a little different. It's actually harder to work with in the sense that you cannot tell right away if it's increasing or decreasing. You literally have to do the sketch. So it's y is equal to ax plus b over cx plus d. And they have a little formula for the vertical asymptote, but you could derive this. Remember, for your vertical asymptote, we'll do this in red, the bottom denominator can never equal to 0. So if you think about that way, cx plus d can never equal to 0. If you isolate the x, it becomes cx cannot equal to negative d. And now you're going to divide by c. So negative d over c. And this is your vertical asymptote formula. If you don't remember it, you can just derive it. Now the horizontal asymptote is going to be, on the standard, it's the k. But in this one, it's going to be y is equal to a over c. So y is equal to a over c. So let's just see what that looks like. Now, if you don't like this form, I don't particularly care for it either. I like to put in the standard form. The standard form, you get it through doing long division. I will show you that on the next few steps after I show the graph for this. So let's do an example. Okay, let's just take an example and analyze this as much as we can. So we're going to take y, or f of x, is equal to 3x plus 2 over x minus 5. So right away, I'm going to know that my vertical asymptote has something to do with the denominator. So my vertical asymptote x minus 5 cannot equal to 0. X cannot equal to 5. So that's going to be at the 5. And my horizontal is literally going to be, since my a is 3 and my c is 1, it's going to be y is equal to a over c. So remember, this is the a, that's the b, this is the c, and this is the d. So my horizontal is going to be 3 over 1. Now, that means that I could draw it out, but I'm going to probably need to do a table of values just so that I know if this is increasing or decreasing. So I'm going to do that really as quick as I can. Let's just do it in solid, preferably. Okay, here we go. So first I'm going to place my asymptotes. So one is at 1, 2, 3, 4, 5. And the horizontals at 1, 2, and 3. It's the first thing you do. You literally put your asymptotes. So I have two choices. I might be going increasing, decreasing like this, or increasing like that. We'll see. I'll just make up a couple of values and see where this goes. So table of values to see if this is increasing or decreasing. I prefer to still make it standard, but let's say you didn't want to do that and you want to do table of values just to see if it's increasing or decreasing. Well, let's just see what happens if we take 0 as x. So over here, what would we have a point? If we don't have a point, that means it's not going to be in this area. So let's just try 0. So try x equals 0. So 3 times 0 plus 2 over 0 minus 5. So if this is my 0 and there's my 0, so 3 times 0 is 0 plus 2 is equal to 2 over negative 5. So that actually gives us a point. That means it is going to be in this quadrant. So at 0, we're at 0.4. So it's going to be like something like this, which means it's going to be something like in this area here, and then obviously in that area. And then this is considered decreasing. If you're not sure, just make up another value. Let's go with what happens when x is, so we knew this was 5. Let's go with more than 5. Let's say what happens when x is 6. Because the asymptote here is x equals 5. So I'm taking a value that's like over here to see if we have a point. So if x is equal to 6, let's just replace it. So let's try x equals 6. So I'm going to go 3 times 6 plus 2 over 6 minus 5. Well, that's 18 plus 2 is 20 over 1. So yeah, I do have a point, and so my drawing is correct. All in all, to say that my graph is decreasing. Now, when we're looking at decreasing, it's going to be always decreasing. When you're looking at the signs, you're looking to get the 0. So we're going to get the zeros for the general function as well, just like we did for the standard. I'll do that in the next screen. So let's find the zeros, and then we're going to analyze that particular one. So find the zeros, which means y is equal to 0. And that means we're going to go 3x plus 2 over x minus 5 is equal to 0. Most people just cross multiply, which is fine. You do that and you say, well, 3x plus 2 is equal to 0 times x minus 5, which makes 0. And then 3x is equal to negative 2. X is equal to negative 2 over 3. That's your 0. And the other thing you can do now is actually talk about when does this function happen to be positive and when is this function negative. So let's just go back to the picture. That means I found that the thirds. That does not look like a drawing that's very well done. So my drawing probably was something more like this. And I would say that this part here doesn't quite exist. There we go. So, like I said, it doesn't really matter. It's as long as you have an idea. Your 0 is going to tell you now when are things positive and when are things negative. So let's look at when are things positive. Things are positive. The function is positive every time it's above the x-axis. Think of this as water. And when is this above the x-axis? So it's all the time here. So you see it's a union. When is this negative? I'll do the negatives in red. It's only here. Of course, all the way up until the asymptote. And you're only looking at the x's. So let's do, first of all, domain. So domain is R except the vertical asymptote, which happens to be 5. The range, only looking at the y, is going to be R except the horizontal asymptote, which was 3. This function is positive, so the sign is positive. Let's look at the picture again. It's positive from negative infinity over here in blue, negative infinity all the way to the 0, which is going to be here. So the 0 is very important. It's a delineation line or point to tell us when it's going to be positive. So that happened to be, what was the number? It was, we did on the next screen, it was negative 2/3. So it's from negative infinity to negative 2/3 included, union, not including the asymptote, to positive, sorry, it was 5, I believe, the asymptote. Scratch that out. 5 to positive infinity. So, and now when is the function negative? The function is negative from your 0. So if you look back at the screen, from this point on down, all the way to the asymptote, which is an x variable. So we're going to go back, and we said it's negative all the way from negative 2/3 included all the way to 5 not included. Okay, so that's pretty much it, and we don't have anything else except for the variation. The variation we said was always decreasing. Now let's say you didn't like this and you wanted to convert to standard. Let's see how to convert to standard.